Chapter 2, Fundamental Data Types, Part 1. Our goals for this chapter are to declare and initialize variables and constants, to understand the properties and limitations of integers and floating point numbers, to appreciate the importance of comments and good code layout, to write academic expressions and assignment statements, to create programs that read and process inputs and display the results, and to learn how to use the Java string type. So variables are temporary holding places in memory where you can hold some value that you're going to need in your program. So programmers name variables to make it easy to tell one from another because a variable occupies a space in memory and you have to be able to determine where in memory you want to go and get this information that you're storing. So that name is what allows you to access it. There are many different types and sizes of storage to hold different things, and we'll talk about the different types of things that we can store. And you declare variables by telling the computer what data type, what type of variable you need, and what name you're going to use for it. So here's an example. When declaring a variable, you can specify the initial value. You don't have to, but you can. It's also where you tell the compiler how big a space to reserve because different data types take up different spaces in memory, different amounts of memory, and so you have to tell the compiler what data type you're using. Java is what is known as a strongly typed language. That means whenever we set up a space in memory, we have to tell the compiler what we're going to store there. Other languages like JavaScript don't require you to specify what data type you're going to be using. So Java is a strongly typed language and we have to articulate what the data type is going to be. So here's an example. The syntax requires us to supply the data type as well as a variable name followed by a semicolon. Alternatively, if we want to assign an initial value, we can articulate the data type, the name, followed by an equal sign, and the initial value, and a semicolon. So in this example, int is the data type. It stands for integer. It's a whole number, and we'll talk about data types in a second. Cans per pack is the name that we are using for this variable, equals 6. The initial value that we are providing is 6. There are 6 cans per pack. Notice that the variable name starts with a lowercase letter and uses that camel casing we talked about before. The lowercase letter for the first letter, starting with lowercase, is the convention that we use when naming variables. For example, let's say that soft drinks are sold in cans and bottles. A store offers a 6-pack of 12-ounce cans for the same price as a 2-liter bottle. Which one should you buy? Their 12 ounces are equal to approximately 0.355 liters. So the variables we're going to need to be able to figure this out are the number of cans per pack, that's going to be a whole number. The number of ounces per can, that's also going to be a whole number. And the number of ounces per bottle, that's going to be a fraction, it's going to be a number with a decimal part because liters are different from ounces, and there are 12 ounces equals approximately 0.355 liters. So each variable has an identifier, a name, and contents. We can specify an initial value when we create it, such as int cans per pack equals 6. You can imagine a useful analogy for thinking about variables is thinking about parking spaces in a parking garage. So the identifier of the parking space might be the number, and the contents would be the car in that space. Here's an example of some variable declarations in Java. Int cans equals 6. The variable name is cans. And the comment, what we're telling another programmer about this statement, is that it declares an integer variable and initializes it with 6. Int total equals cans plus bottles. We're declaring a variable called total, and we are providing an initial value that is equal to the quantity stored in the variable cans plus the quantity stored in the variable bottles. This is just for that moment. So if there's 6 in the variable cans and 2 in the variable bottles, the amount in total would be 8. If you then later change bottles to be equal to, say, 20, it's not going to update total unless you run a statement like total equals cans plus bottles. Again, so when we have int total equals cans plus bottles, you're not forming a dynamic link that's going to update all the time. It's just at that moment what value's in cans, add it to the value that's in bottles, and store that result in the variable called total. So if we try to declare a variable called bottles and we don't provide the data type, that will result in an error. Furthermore, if we try to declare a variable int volume and set it equal to 2 with double quotes around it, recall that the double quotes denote a string, and that's just text. We can't do math with it. And Java does not know how to automatically change that text into the numeric value. So leave off the double quotes and that will be just fine. Looking at the next line, int cans per pack, that declares a variable called cans per pack, but it does not provide an initial value. Similarly, int dollars, comma, cents declares two variables, one called dollars, one called cents, and they each store a whole number. They are both integers. There are three different types of variables that we will use in Chapter 2, and one is a whole number. It has no fractional part. That's an int. The second one is a number with a fractional part. We're going to use the double data type. And the third is a group of characters or a word, and that's going to be a string. Notice that string has an uppercase S on it, whereas double and int do not start with an uppercase. That's because double and int are what's called primitive types, and string is a reference type, and we'll talk about that difference shortly. So int cans per pack equals 6. We're specifying the data type, the name, and the initial value. Double can volume equals 12.0. Because double allows us to have a fractional part, we can say 12.0 rather than 12. Back to the garage analogy, parking spaces can be different sizes for different types of vehicles. So a bicycle will take up less space than a motorcycle, which will take up less space than a full-size vehicle, which is completely different from an electric vehicle. It's got to be parked where it's got something to plug into. So each one of these is a parking space, but they're all different in some way. Similarly, we need different data types to store different values. An int does not have a fractional part because sometimes we only want to work with whole numbers. For example, if I want to store the number of students in my class, I don't want a fractional part because there's not part of a student. They're all whole number. Each person is a whole number.